Word on this computer. Yes. Okay, fine. Den er ikke på test, Stine.
Den er ikke på det.
Nei. Okay. Sorry for the slides technical issues. I have no idea how my screen looks for everyone else. We're having a hybrid workshop. This is interesting. I've never had a hybrid workshop. So we have at least 4 people on Zoom, and we can't actually see your faces. So if you have questions, please unmute yourself and just ask them. I can see if you write something in the chat too, but it's easier if you just ask a question. But we are recording, so if you ask a question, you will be on the recording. So sorry about that. But I'll try to pay attention to the chat as well and make sure everyone can follow along. So this time we have another dry subject, and I promise not all subjects I'm going to cover are going to be this dry, but it is super important and something we all should think about, how to organize our files in our workflow. And just like a disclaimer, I am not the best at this myself. So like, I know all these principles. That doesn't mean that I always actually follow them myself, but I'm hoping by going through it together, we can all kind of help each other deal with our project workflows better collectively. And at least like a good project workflow and a good way of organizing your file, it does help you in the long run, yourself and your collaborators in the long run, even though it's kind of boring to think about. There we go. So just like a very, very, very short recap of what we covered last time. If you weren't here last time and you want to have a look at what we did, we have a YouTube video on that and slides online. I posted that on our internal Slack, so you can find them there. So why we care about project management? We care because it's good to have a portable project, meaning that you can move the project folder around to different places, so you can reorganize your computer kind of organization without messing up all of your scripts. Because working in like the default way we learned to work in R when we started, it would mean if you moved your project somewhere, you would need to change all of the paths in all of your scripts, and that's a bit of annoyance. And you will change computers, and you will reorganize your files, and you will share your code with other people because we are working in a collaborative lab. So having a good and nice portable project just makes life easier for everyone. And we also want it for reproducibility, so which is the ability to rerun the entire process from scratch. Which is, it's not just good for when we get reviews and we literally have to rerun the process from scratch, because when have we ever gotten a review without having to redo everything all over again? It is also good for the future you, or even the present you, that you can reproduce what you've been doing. And it's good for your collaborators and helpers, so they can help you more easily, or they can follow your code more easily by running it themselves. So in a good project workflow, all necessary files for a project are contained in the project folder and are referenced relatively to the project root. And all necessary outputs in the project are created by code in the project, so they're always possible to reproduce. And all the code can be run in fresh sessions and produce the same output every time. And when I say same output, I am allowing for small decimal changes, which are likely to occur with some methods, but in all, the same thing should happen again and again when you run it in fresh code. And lastly, a good project workflow doesn't force other users to change the way they work themselves. We don't install packages without asking people to do that explicitly themselves and such things. And we don't change options for people. So when we were talking about portability a lot last time, we were talking about the here package, which helps us reference the files in our project relative to our project groups. As long as your project is set up as an R project file, as an R project, here just knows where the root of the project is, and it can reference all your files from there. And today we're going to cover, to show a little bit the difference between using here inside a project and not using here inside a project, and what the differences can be more clearly, because I think last time it was still a bit maybe vague why here is so clever, but we will see why today. And here's just some small examples of my own project route for my talks project, because I have a R project with all of my talks in it, which is literally where the slide exists. So here starts at the folder on my local computer where my talks project is, and all of the, and I can reference the slides for this specific talk by saying here, it's in here, the root of my project in the slides folder, in a folder called 2022-0203 R project and index, which is the actual slides file, the file that creates the slides, which is probably all way more information than you need to know, but it's a way to reference this file directly from the project root from anywhere in my project. So yeah, last time we talked about our studio projects, and we had a very, very, very short recap of that now. And today we're going to talk a bit more about organizing our files and our workflow, and how we can kind of use the different files in different places in our project easily using the here package. But now I lost some indentation here, so that's very messy. Well, here we go. So when it comes to folder structure, I mentioned this very briefly last time. I'm going to try highlighting. So this should all be part of the data part. So we have a data folder, which we would usually put all the data that we're using for a specific project in. Once you've written data, you should never write back to it from R. This is not the place where you store your, data is the place you store your raw data, or the data that you've manipulated in any way. We will store those another place. So data should be treated as what we would call in technical terms, a read-only folder. It's a place you only get data from, you never put data in. And that the reason we want to do that is so we don't inadvertently overwrite our raw data. And suddenly we put ourselves in a situation where it's very, very hard to reproduce what we had before because we overwrote our raw data. That's kind of messy. Obviously, in LCBC, the data is always somewhere else as well. So we are usually very able to reproduce your data again, but that means doing manual things over again. And we all hate doing manual things over and over again. So try treating data as a read-only place once you've placed the data you need there. Then we have a results folder, which you should treat as a write-to folder. So all the results you are getting and stuff you want to store for long term, that should go in the results folder. Model outputs or even plots or whatever you want, like it should go in the results. That's very clear place. You can treat it as disposable, meaning things can be overwritten there unless they're the results you, for historical reasons, want to keep over time. And then you should make sure you name them in a way that they won't easily be overwritten. And we're going to talk about file names very shortly. I usually have a docs folder where I put some documentation or our Markdown files. And we'll be working a bit in our Markdown file today, which is why I asked you to install our Markdown package. Because our Markdown files are actually a really nice way to set up easier workflows. So I would not set up a workflow that requires like an hour of computation time in an R Markdown file. That is a bit too much. But if you're just doing things that need like a minute or two to run, an R Markdown file is a great place to put it, because then you can kind of collect your entire workflow in the same spot. You read in the data, you do some analysis, you plot, you make a table, and you have that all in the same nice document, actually creating some nice rendered output as well. So that's what we're going to use. And our Markdown files actually run always in clean sessions. So they're a really nice way to force us to learn how to work in clean sessions. I've mentioned that a folder called R. This is a very R-specific kind of convention. If you are advanced enough that you're writing your own functions or ggplot themes, I know most of us are not there yet. These are conventionally placed in the R folder, and then you source them into different places, so you can use the same functions several places without having to kind of rewrite them all over the place. It's quite convenient once you get there. And then there's the scripts or the analysis folder. I usually call, God, I hate that I lost the indentation. I'm not sure what happened here. And then there's the scripts or analysis folder. I usually call it scripts, so that's just what I'm used to. And these are files with like fuller, longer analysis pipelines that you wouldn't necessarily run in an R Markdown like 100 times a day. Maybe that's something that takes a long time to compute, and you want to run it once. You write the output to the results folder, and then you grab those results, for instance, from your R Markdown file to work on further. And you only run those scripts on demand, basically. When you need to update something, you've added a new participant or whatever, and you need to redo the computation, then you can rerun the scripts. Otherwise, you can just run the R Markdown file, for instance. Questions so far? There are a lot of folders to talk about now. And then we have some files that we would usually add. So I would usually add a Readme file, either as an R Markdown or as a plain Markdown. That kind of describes what the content of this project is like. What is the purpose of this project? How should you, as a user that's never seen the project before, kind of interact with this project? Like, what files should you be looking at first? Like, in what order should scripts be run? Stuff like that. Like, describe to someone that is not you what is doing here, or describe to yourself in 6 months when you get the review what the hell you were doing when you were doing this stuff. Documentation. So this is a type of documentation. It's boring because when you're doing it, it's also obvious that this is like what you're doing. But I promise you, in 6 months or even in a month, you've forgotten why you've done things in the way you've done, the order of stuff, and then actually have had past you write down what you were doing. Saves you a lot of time in the future trying to retrace your steps. The description file is a very R-specific file, and I'm not particularly going to talk about it now because it's kind of weird. It's not necessary to have there. It's good to have if you're doing very R-specific things later, but it will be by default populated for you if you use the project creator that I made in the LCBC package. You can ignore it for now, and we can cover it at a later time what this weird file is and why it's smart to have it there. And if you plan on putting things on GitHub, I mean, the Readme file is also great to have if you're putting it on GitHub. If you're planning on putting things on GitHub or a GitHub equivalent like GitLab or Bitbucket or something like that, license file is important so that people know how they can use the project content in the future. Like again, I'm not going to cover different types of licenses because that's probably like a 2-week course and I don't understand half of them. I put a link in the slide to like how to choose a license. There's a web page that can help you figure that out. But there are some like guidelines you can use. So for me, all my teaching materials, I always license with something called CC BY, meaning anyone can use it without crediting me, because it's teaching material and I don't need the credit for my teaching material. But anything I develop in terms of software or stuff we use here at LCBC, I usually will use something called an MIT license, which means people can use, alter whatever they want with it, but they have to credit me as the main author of the source code, so that it makes sure that I get some credit for any like derivative work based on what I've done. And then the citation file is also great because it dictates how people should cite that they've used your content in some way. And that's particularly important if your repository is linked to a paper you've published or you're trying to publish. Once it's published, or you have it as a preprint, make sure you make a citation file that links to that. And there's a link here on how to create a good citation file in the slides, so you can click on that and have a look if you need it. But it's important, especially for us as academics, that this citation file is there, because this is how we get evaluated, right? Unfortunately, but that is how it is. Okay, so we're going to talk a bit about file naming, because I see a lot of different file naming schemas around the house, and I think it's good if we can collectively kind of agree a little bit on a smart way of naming files that are easy for us to understand now and in the future what is there, but is also easy for computers to interact with in a nice way. So, and when I'm talking about file naming for this section that's coming now, that's particularly for the contents of data, results, scripts, and scripts. The others are a little bit different. So file names should be easy for machines to read. It should be easy for humans to read. The file name should give you a general idea of what the content of the file is at a glance, and like, not detail, but at least like, oh, this contains results, or oh, this contains error codes from something. I like should have some sort of idea what's in there. And then we should have like a general idea of what type of file to store things in. Now, so if you're using the R folder, none of the things I'm going to talk about now about file naming counts for the R folder, except for don't have spaces in the file names. But the R folder is a little bit different since it contains functions you want to use different places. Don't care so much about machine readability, care more about human readability, so you know what the file contains. But anyway, so when we're talking about machine reading, we have to remember that machines are extremely pedantic. Like, they don't automatically understand that when you made a capital M, when you wrote the file name and you wanted to access the file name from a computer and you wrote it with a small m, that this is the same file. Any human would easily understand that this is the same file, but computers are like, no, this is not the same file. One has a capital M and the other has a small m, and that is different. So be consistent and be meticulous, both when you're naming and when you're trying to access the files. And some machines are smarter or more clever than others. We should write file names in the way that like the dumbest of them can understand, which is why we should avoid spaces. Most modern computers can easily understand a file name that contains a white space. In space, I mean like a place where there's literally nothing. But the most stupid of them don't. And in many cases, we have to write like annoying extra things to access files that have white space in them. As a programmer, this is very frustrating. Like, you have no idea the amount of frustration a white space in a file name can give me. And usually, rather than try to programmatically go around it, I will go to the file and reading it because it's just cleaner. So for the sake of me and all of us who program and all of you who are now learning to program, stop using white space in your filings. I recommend using a single dash. I often use that, but we will see also very soon that there are exceptions to my recommendation of this. Use small case letters. It's just easier. And you don't have to like use the shift button to make it larger. Just like make small letters. It's a little less typing and it's less to remember, oh, was this capitalized but not this or whatever. No, it was all small case and that's it. No confusion. And do use numbers and use them in a clever way. And we will cover how using numbers in a clever way can help you organize your folders really, really neatly. And it pays off to think you're going to make a lot more files than you think you're going to make. Because you're always going to end up making more files than you think you're going to make. And thinking of that in advance can usually help you avoid having to do larger renaming again to maintain good folder structure. So when machines list files, they list them in numeric alphabetic order, which means they will list anything that starts with a number first and then run them alphabetically. So here I have 5 files. The 2 first ones start with a number. Oh, they're nicely like numerically after each other, 1 and 2, very nice. And then we have file 1, file 3, and file 2. File 2 obviously is after file 3 because the W comes after the H, and that's how they get organized, and that's not neat. Again, as a human, this is not a problem. But if you have like a million of files like these, it actually does start getting a bit confusing. Like, oh, am I missing number 2? Where is number 2? No, number 2 is like way down the list because it has a W in it. And it gets frustrating. And number 4, if we had that here, would come after file 1. So it would be file 1, file 4, file 3, file 2. And then you have to start like using a lot of cognitive capacity to make sure that you're actually like the files you're expecting are there. So we could do it. But then also like computer is also not smart enough to understand that 10 comes after 9 because it starts with a 1. Oh, come on, computer. So it will always list the number 10 or any 10s after the number 1 before number 2 comes because it starts with a 1. Annoying. So how do we avoid that? So we would usually do something we call 0 padding. So 0 padding is adding a 0 in front of the numbers that are lower than, for instance, 10. So any number, in this case, if we're sticking to, we're assuming we're never going to make more than 99 files of the same type, we just stick a 0 in front of numbers 1 to 9 to make sure that they list in front or above 10. And then they come in very nice and neat order. I very often 0 pad with 2 zeros. I mean, I've never actually made 100. You never know. And it doesn't really cost me a lot to just have 001 rather than 01. And it makes sure that my files come in like in much neater order. And if you wanna start the file name with a number or end it with a number, that's kind of up to you what's the most convenient. I usually use these 2 conventions in 2 different ways. So if I need something run in a specific order, like you need to run this script first, and then this thing, and then the other one, I would usually call them 1 initial script, 02, whatever that one does, I don't know, plot the raw data, number 3, run the analysis, number 4, create the results. then the ending of the file name doesn't matter. The ending of the file name becomes a description of what it does, and the numbers are an indication of the order of which they should be run. While, for instance, if I'm writing lots of different results, I would maybe rather write them like this, like results 1, results 2, and then maybe it's like some explanation of what these are the results of in the end. But in most cases, if I'm writing results or stuff like that, I will use dates. Dates are great because they are ordered date-wise if they're done correctly. So on the top part here, I mean, they are dates, but all these dates are written in different ways. One of them is actually super confusing, like 220103, depending, I mean, if you're in Europe, you're reading this in one specific way. If your coworker was American, this could easily be the 1st of March rather than January 3rd, which is how I would have read it, right? Because Americans are weird and they do year, day, month. And they're not sorted neatly, right? Or maybe it would say actually the 22nd of January, 2003. Like, it's like, what is this date? I am not sure. Not sure. Which is why we recommend using the ISO formatted date, which is year, 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 month, month, date, date, which is what I've done below here. Which then, like, now you know exactly what this date is. Because obviously this, if we're assuming that this is, that all these dates are written in the same way, the last 2 numbers have to be the date, like the day of the month, because there's no month 13 or 28, which means that the second 2 numbers have to be the month, and obviously the first 4 have to be the year. So it becomes much, much clearer what dates you're actually looking at. And then you will know, like, and then here I also added some text about what the content of the file is like. So the first one is like the results we had when we did our first initial submission to this paper, like these are there. And then the revision came and we did some stuff. And then we did some more stuff. And this, like the third option here, are like the results we sent with the revised paper. It becomes a bit clearer what you're actually dealing with. And then, like I said before, use the dash to signify white space. But I actually have, I actually usually name my files with different types of delimiters for different types of white space. So in this, and that has to do with me wanting to actually access some of the information in the file name programmatically. So I know if I do this, if I think about this a little bit, I can access the file name in a cleverer way if I use separators, different types of separators for different parts of the naming of the file. So in this case, I've used the underscore for everything that would have been a white space in the file name. And when I try to split the file names by this underscore, each of the file names have like different lengths. So the first file name gets 1, 2, 3, 4 separate words in it, because that's what it has. It's a date, initial, submission, results. And then the next one only has 2. It's just a date and then results. And then the third has 3. Which is fine. I mean, at least the date is in one single place. That's nice and neat. But if instead of using the underscore for the white space between the words in my text, I use the dash, I could very easily separate the date part of the file name from the explanatory part of the file name from each other. and always access the same type of thing no matter what. So in the first result, it's always the date, and in the second, it's the text information. And though this seems like a very weird thing to want to have access to, but this is the type of thing I do quite often with LCBC data, this type of accessing of information. And sometimes in my scripts, if I'm super lazy, which I am sometimes, I will write a little kind of wrapper script that will always, like, for instance, if I have lots of different raw data that I gathered at different dates, I just wanted to grab the newest one. I will write a little script that looks for like the newest date. And then things like this becomes very convenient for me. Because then I don't have to go in and manually add the file name I want to analyze. I just always want to analyze the newest one. And then we have like the human reading part. So always like try to add a little bit, a short little bit in your file name that gives you a clear understanding of what the content of the file is as a human. Not just for you, but also like for future people. So like, please do not, like, I've done this. I have no idea how many times I've done this. The final results, the final results, the finished results 1, 2, 3, 4, 5. And I have so many. I think my whole thesis folder for my PhD, I have like at least 5 or 6 different final versions.
And then done.
And then done. I actually think my last one was merged. Then I merged everything, and it was actually done. But like, okay, in this case, at least we have dates. So we are actually able to figure out which one is the newest, and we can kind of assume that like the newest one is the one you actually used. Hopefully. But that's not necessarily always the case, but yeah. But it doesn't really help us all that much. But like things like this is like, so we have the first submission results, and then we have revision round 1, revision round 2. Ooh, revision round 2, the ones with no sex in like the variables for our models. These make it a little bit easier to understand as a human what the content of the file is. So we don't have to like think, like we don't have to go through every line of our code to figure out like which file is what. And then lastly, before we actually start doing some stuff, I have no idea what time is. Yeah. Choosing file formats is important. Like we will cover Git and GitHub at like the last session we're having. So we'll come a bit more into file formats then, because it has a huge role to play when we're dealing with version control. But if you're saving data tables, like data that has columns and rows, please always choose a text file to save them in. And I don't really care what type of text file you use in LCBC. We usually use tab separated data, most of us, with the extension .tab or .tsv. That is that's what's most common here. You can also use CSV, which is comma or semicolon separated. In Norway, semicolon separators is more common because we use the comma for decimal separators. That's a bit confusing. There's also an extension called DAT, which is usually a fixed width type. It's very uncommon, but I know that geneticists love using fixed width data. And then text usually signifies space separated. So just to be like in the clear here, the file extension name is just conventions. You can call it whatever you want. At the end, it will still be a text file. It's just using the common names will make it easier for other programs to understand what type of content actually is in there. But these are all just conventions. So they could all be text, for instance, or all be CSV, even though they're space or tab separated. It doesn't actually have an effect on the content of the file, what the extension is when it comes to text files. In other cases, we can sometimes save other types of data. And since we're like very R centric in these workshops, you can store entire R objects or even the entire R environment as RDA, RDS, or R data. And there can be reasons for doing that, but please note, if you ever save a statistical output object, like from a linear mixed model or a normal normal linear regression or anything like that, the data is contained in the object. Which means that if you save it and you put that file online, you have exposed our data online. So please be careful and think about it before you do that. We have ways of removing the data from those objects. And so there are ways to go around that and still actually share the R object. That is fine. But just be careful and think about it before you do something like that. And we have, if you've first done it, also don't panic. Let me or Ingen know there are ways of purging history from Git so we can fix it. But just be aware that this is a potential data breach area. Okay, I have had to be a bit stricter, but just but the biggest point is if you have done it, don't panic. Let us know. We can fix it. Right? We can fix it. Okay, so short recap before I actually start doing some small things. Use here to find relevant paths in your project, very important. Use source, we will use that maybe not today, maybe next time, to load functions or run scripts from other files. So for instance, this code below here will run the R script called ggplotfuncs that's contained in the R folder from wherever it is. In this case, because I have it in R, it won't actually run anything, but it will make some functions available for me so I can use them in whatever I'm doing. And then use here again to save your outputs into like designated spaces. So in the first one here, we're saving a Tsv file of something I have in an object called my data frame to results to a file called this date results.txt. Or you can save a ggplot object, which is also very possible, to a folder called figures with today's date, spaghetti, age, CVLT, which like in my case, I would understand this is a scatter plot with like spaghetti lines between participants of age and CVLT on the axis. So I know what that's all about. Yes.
Is there a nice way for it to actually pick up today's date without you actually telling it?
It is. There we have that. I didn't like, and the first time I made the slide, I had that, but then I decided it was a bit complicated, so I dropped it. But we have, I will show that at some point. There are ways to automatically take today's date and put it in there so that we don't accidentally overwrite. But you could then accidentally overwrite like the other plots you've made today if you're not. Make sure that you know. Yeah. That you know what you're doing, but yes, we have ways of doing that programmatically. So let's do some stuff. And I'm gonna stop sharing because I need to share my whole screen, won't I? Yeah. I'm gonna need to fix that before I put this video anywhere. Okay, so here's my, I'm gonna make it a bit bigger. This is my talks project, which is not something we're gonna be working on. So we're gonna create a new project. If you've all installed the LCBCR package, you might be able to do, didn't that actually do anything? Be able to follow that. I hope you can. So we're going to start a new project. And then my computer suddenly went super slow. And we're going to make a new directory. And I've installed the LCBCR package, so I have this option to create an LCBC paper project. So this was something Knut actually mentioned might be a good idea. And I agreed, it was a very, very good idea. I'm sorry, I didn't think of it myself. So I basically kind of made us a little lab template of how to set up a paper project. So we can click on that and we should give it a name. So I'm going to call it workshop. Workshop project. And I'm going to put it in the subdirectory of my workspace LCBC folder. This is the place I put everything I work on for LCBC in. I try to keep myself organized. It's not always successful, but that's what I'm going to try. And well, okay, that's ambiguous. I'm just going to leave this as untitled because it doesn't matter, and I'm going to change stuff. And I am going to let it initiate Git version control. We're covering that in 2 sessions time, so we might as well just have it started for us. We're going to cover the RN package next time, but we're not going to initiate it now because we're doing that next time. So I'd rather wait a bit with that. And we're going to create the project. And then our studio is going to do some stuff and open up a new project for us. And I hope that's what happened with everyone else. I've literally never had anyone else run that piece of code except myself. So very, very much hope it works the same for everyone. So now you should be in like a project folder that you made. The first thing that opens is actually the description file that I decided not to describe to you all, and you don't have to know about it yet, but it's basically already set up for you to begin with. But we're just going to close it because it doesn't need to be there. There's a Readme file, which is Readme our Markdown document, and it tells you a little bit about what the intent of this project template is, and help you kind of fill in the information that needs to go there for your specific project, like write some description about what you're doing here. And then I've added some information about what I would usually put in the different folders. If you're organizing it very differently, you should add a different type of description. There's another file called Untitled that should be opened by default. And this is the file we're going to work a little bit in. Untitled? You don't get the Untitled one? No, okay, that's interesting. Did you get it? No. Huh. Right. I don't know why, but you can make one. So for everyone that didn't get the Untitled file, that probably means that So is it just I who got the Untitled file, or did anyone else actually also get it? Here's no one else got it. So the function's not working exactly as I'm expecting, but that's fine. I will figure out why. Good for me to know. That probably also means that I have some more folders than the rest of you have. So if you look in your files pane, for me, I have Git and Git ignore and artwork user. I have data, description, docs, figures, R, results and script, and a README. You might or might not see the files that start with the docs. That depends on your system setup. You can't see them. No, that's fine. You don't need to see them. You're just curious. Okay, so does everyone have the docs folder? That's another one. No, it's interesting. So you're going to make a new folder called docs. So press on the new folder button. Yep. I'll help you afterwards. Press on the new folder button and create a folder called docs, which is where we're going to put in our Markdown file. My docs already exist, so I'm not going to actually do this. You can go into it. I have a folder called example presentation, which you probably don't have in there since you don't have a docs folder. So we can start a new R Markdown file from the file creation pane. So if you go to this arrow thingy next to the file creation and click on R Markdown. And we're just going to create an HTML called test doc. I have no idea how you guys on Zoom are following, or if you can, so let me know if you can't. And we're going to say okay. And I'm going to close everything else and just have the test doc open, which is actually called Untitled, because I didn't give it another name because I'm a bit stupid. This opens like a standard R Markdown file with some example stuff in it. And let's just knit it so we know that it works. So in an R Markdown file, you do something called knitting, which turns this weird format into a rendered nicer format. In our case, we have chosen to render it as an HTML document because that works easiest for all computers. So if we press the lovely, lovely knit button up here. Oh yeah, that's because it's going to ask me to save it somewhere. That's why. We're going to save it in the docs folder. I know that's very, very tiny, probably for some of you, but I can't enlarge this particular window. And we're going to call it test doc because I can't think of anything else right now. So you see, I'm already breaking what I've been teaching you. I don't know what to call it, so I'm just going to call it test for now. And I'm going to have to rename it later when I figure out what its content actually is. And make sure it goes in the docs folder because that's where we want it. And questions should come around now. But which you're should already be there. Anyway. Navigating file folder structures are not always easy. Yes, so I'm going to make that. And then it makes this thing. Did that actually run? Is the question. Once you had selected a name and a place, did it run? I'm seeing some heads saying yes, and I'm not seeing all of them. Please ask for help if you're stuck. I'm very happy to help. Yes? Alpe?
Jeg falt av litt før det, men jeg hører.
Okay, we can go gjennom dette.
Jeg kan
We have one that's stuck, but I will help her unstuck herself later. So this is like, okay, it's like it's not the most beautiful thing you've seen in the world, but it shows us a summary of some built-in data in R and a plot. And this is basically what we can do in an R Markdown file. We can write text and have it rendered as text, and we can write code and have the code execute and actually show the output directly in the document, which is very convenient when you're doing analyses. So I'm actually going to delete all of this blah. It doesn't have any value for me, but I'm going to leave the setup chunk in the beginning because I always do. I literally usually always start an R Markdown document like this because I never remember what the syntax for this 3 lines of code. So I just want it there because it's very convenient. I'm not going to cover what it does. I'll do that another time. But it's just convenient to have there, and I never remember it. So I always initiate it like this. So here we are, and we want to do some stuff. We should, first of all, put some data into our data folder. And I'm going to write a piece of code that will do that for us so that we can access the data later. It's just like an easy way for us all to work on the same data. So we're going to do, you write. Actually, I should do that in the console. It's not so easy when you have a small screen. So I'm in my R console, which probably for you is not the bottom right, but no, the top right, but the bottom right. Oh, you would have thought at soon 40 years old, I know the difference between left and right. Okay, we're going to go right table. We're going to be as boring as Iris. Iris is a built-in data set in R. We're just going to write it to a file so that we can access the file. And the file is going to be in here, data, iris, .tsv, and we need to tell R a couple of things so that the file looks nice, because by default, R saves files not so nicely, in my opinion. So we're going to say that the separator is a tab. This is how you do that. You tell it that it's a tab by writing this very weird thing, the backward slash and the T. We're going to say that row names is false, or else the first column in the file is going to be the numbered rows of the data set, and it's not going to have a column name. And it's really annoying to read the data later, so we're not going to do that. This should be it. And I can post that in, oh yeah, need to actually library here. I haven't loaded in the here library, so R is telling me directly like, hey, I can't find the function called here, so boo on you. I can't do what you're asking me to, so I need to load the library here. And then I use my arrows on my keyboard while I'm in the console and press the up button. And then I will go through the history of what's in the console, which is like super convenient. And then I'm going to try running that piece of code again, and then it succeeded. So I'm just going to post that code in the chat for you all, so that if you're struggling to type it correctly, you can paste it.
Wait, I have other region.
Oh yeah, that's true. You have a weird non-Norwegian. Yeah.
Like so many times. So in silence.
We need to fix that keyboard.
But if you go into just Google /
Yeah,
and then copy paste it into the.
that's another way of doing it. Or you can grab, I have it in the chat now. Electra's getting an error message.
Oh my.
You're in the lagringshotell. That's actually quite unexpected. Actually, does your data folder exist? That's the second question. Have you made a data folder? That would, that's my bad. Because my project was actually set up the way I wanted it to, and yours for some reason were not, and I have to figure out why. You need to make a data folder. So it's a weird error message. So this is the reason I can read this easily, because I've seen it like 100 times before. And my first idea is always, does the folder exist? And in most cases, it does not. It will not make the path for you. So it will make the file, but if the folder you're trying to put it into doesn't exist, it will fail. You have to make that yourself.
And now it's working.
And now it's working. Good. Electra, I hope that's what the error was for you too. Awesome. I mean, these things are actually great that are happening because it all teaches us something. And learning to read our error messages really is like an art form in itself. They are like, some functions have awesome error messages and almost like give you the code that you want to run. In most cases, it looks like this and you have no idea what it's talking about. And you kind of try to have to read through the lines, and with trial and error, you learn what it is. So if we look in the data folder now, there should be a file called iris tsv in there because we just put it there, right? Great. And the whole reason we put it there was so we could access it from our test document. Because this is like the first place we're going to see why here is an amazing piece of engineering. So we're going to make something called a code check. You can go to the top here to this weird +C thing, and we're going to make an R check. So in an R Markdown file, it's a little bit different than in a script. In a script, more or less everything is code unless you have a hashtag in front of it, right? And that's a comment. An R Markdown script is kind of like the reverse. So everything you write outside of what we call code fences, these 3 backticks, everything outside of that is normal text. Anything inside the code fences is code. And in this case, we're going to write mostly R code. So they're all going to have this curly braces in R, indicating to the program that it should be executing R code in here. If you're working in another type of program, there are also other languages you can use in R Markdown code chunks validly. So you can use Bash or Python or D3, which is a type of JavaScript. You can use JavaScript directly if you want. SQL, there's lots of stuff. There's even ones that are not listed here. So if you're doing web development, it will also run CSS if you've done that. So actually know people who work only in Python, but they actually do make R Markdown documents with Python chunks in them because it's a very powerful piece of machinery. Anyway, that was just like a bit. So in here, in between the 3 backtick things, we're going to put our code that we're going to use. And we're going to start by reading in the data, which is probably like the first part in most pieces of code, is to get some data to work on. So we're going to create an object called iris by using read delim, which reads a tab separated file from, and I'm going to do this without here first to just show why we want to use here. Iris.tc. So I know, and if I've done everything correctly, if I run this piece of code myself right now with command enter, did I not type that correctly? Oh yeah, no, I know. Actually, I'm hoping that actually happened for you all as well. Did it? If you try running that piece of code, does it error?
Yes. No.
Yeah, okay. No. Okay, so there are reasons. I was kind of hoping that it would not. So there in the knit button, you can press this little arrow down, and there's a thing called the knit directory. And for some of you, I'm assuming it's set to be the project directory. And for some, it's set to be the document directory. Yours is document. And yours works?
Yeah. Just that code, like the
Yeah.
iris read middle. Yeah.
That shouldn't work for you. Is your data folder within the docs folder, or did you not make the R Markdown document within docs?
Yeah, no, it's outside of docs.
That's why. We are good. Fine, we have an explanation. So, yeah. So the reason it's not working is because we're asking it to knit in the document directory, meaning it's looking for data in docs data iris instead of going outside of docs and then looking like in the project root directory. We can like switch it to the project directory when it knits, but this will reset for users when they try running your documents. So if you give your project to someone else, this is an RStudio setting that's not inherited by the project in any way. So for them, it wouldn't work. So it's failing, blah. But this is why here is great. So if we instead wrap this in here, this is also going to fail. Well, actually, it's not going to fail because I loaded here. So this is going to work while I'm working in it. So it's actually, it's a bit like working on a script, right? You've loaded a library and you've forgotten to put the library loading inside your script. So you've kind of already forgotten that's the thing you want to do. But the good thing with an R Markdown is that usually you will not just work on it interactively, which is what we're calling this. We're telling it to run code. We will tell it to run by the machine. So we're going to tell it to run by knit. And if we try to knit, it will fail. And you can barely see the error message because it's a bit small, but I'm getting the same error message as I did before because I hadn't loaded here. And this is because when you knit an R Markdown document, the session is always fresh. An R Markdown document forces you to work reproducibly because it will not knit if everything you need is not in the code, including the library calls. So when you're running things interactively, and when I say interactively, I mean I'm going through the code piece by piece and running command, run, command, run, command, run. Knitting is not an interactive thing. You push the button and then it just does the whole thing at once. The machine does everything. So when it's not interactive, it needs everything to be in there and it's always clean. So it doesn't know what's in when we run knit, it doesn't know what's in my environment from before. It doesn't know which libraries I've already loaded. It's completely agnostic to everything, basically. It's just going, I'm starting anew. So it's a nice way of forcing ourselves to work reproducibly. That doesn't mean that like everything you do in an R Markdown document will forever be reproducible. I have managed to make R Markdown documents that have not been, but you get better slowly. So what do we need to get this code running? We need to add a library call. I will usually add library calls in this top part, which is the setup chunk. So I will add library here at the top. And then when I type knit, then it will first load the library, and then it will try reading in the data. And then it should be good. So if I try knitting that, yay! I mean, it's completely nonsensical. It's like the most boring document I've ever made, but it ran and there's no error. So that's good. So I'm actually a bit surprised at that. Oh yeah, because it says include false. I'm gonna pop it. I'm actually gonna pop the library call into this other one because it's gonna do something slightly different. So did I completely close the document or did I just? Okay, so this is what we see now. We just see the call that I'm reading in the data, which is good. I mean, depending on who you're like sharing code with or whatever, having the code that is run in the document can be good. It depends a little bit. Often if I make reports to Anders and Christina, I'll not actually show the code in the document. I'll only show the output of the code because they're not interested in seeing like my nitty-gritty, sometimes extremely hacky pieces of code to get things working. They just want the output. But if I'm sharing with, for instance, Øystein or Inge, or maybe someone who wants to learn more about like the process behind it, I will make sure that the code is also outputted, not just the output of the code, so that they can see it. And the reason I'm mentioning you this is because there's a little piece here in the code, in the chunk setup that says include false. It means that whatever is run in this code, if it has any output, it will not show in the end results, and it doesn't show the code that it's been run. So the document we had before, you couldn't actually see that I loaded the library here, which in most cases, it doesn't really matter to show exactly which libraries you're loading. Maybe depends a little bit who's running stuff, but it could be nice to show. And in the other code chunk here, I haven't said anything extra, like, so it should show everything. It should show that I'm calling library here, and it should show whatever output library here might show when we run it. So if we're running it, we get something a little bit extra. So it's showing in gray here the library call, and then it's actually showing where the project is. So that's like very clear where I ran it from. So that can be quite convenient. And we're going to talk more about our Markdown another time. But this is what's great about our Markdown. It's forcing us to be a little bit more explicit and making sure that whenever we knit, it runs afresh. And if it can run without error, it means that we've saved everything we needed to save to actually have the code run as expected. Because usually in a script, if for some reason we're coming back to it after a couple of months and it's not running as expected anymore, it's because we forgot to save some piece of code that made something that we needed further down the line. And this can happen to anyone. I mean, we all forget this. But if you come into the habit of running in our Markdown documents and like re-knitting fairly often, you will very easily catch like, ooh, I forgot to add this thing. And it's so much easier to put that in when you only did it like 10 minutes ago, because you remember that that's what you made 10 minutes ago. Yeah, so that was a bit of today. We've gone a little bit over time, so I'm not going to keep everyone longer. Unless there are questions, very happy to answer them. And there's crickets. I never know if there are no questions, if that's because I'm super clear or I'm super intimidating, so no one dares asking me any questions. Oh, should have known that that was also the end of an hour when my break reminder just come back on. Okay, then, yes, good. I know that file naming is not like the most fun thing in the world to talk about, but it is quite important. In the long run, it is quite important. And I wish I had more knowledge about it when I was doing my PhD.
So do I.
Because when I look at my old PhD project folders, they are so messy, and I have no, like I have a paper that I'm literally, it's just died on my desk because I can't sit down for like probably 2 weeks and try to figure out what code does what, because it's so messy. And it's such a shame. So I want to spare you all from that agony, hopefully. We're talking about something as dry as file naming, but hopefully saving you some headache in the future. Yeah. So we'll continue with package management next time, which I'm really looking forward to because we're going to use a package I know of and I've seen in action, but never actually used myself. So it's a way of forcing myself as well to learn more about it, to implement it. So that's going to be like a collaborative learning experience for all of us. But it looks very promising in terms of having reproducible code and managing packages, which is actually quite difficult in R when you have things running over long periods of time, which science usually is. So looking forward to that. And thanks everyone for joining in. Thank you. You're welcome. Oh yeah, it's the other user that's recording, so I need to figure that out. Oh no, I hope it's not locked now. Okay, no, okay. I'm just gonna end it.